vaguely. I know they've got some papers on there. So
yeah, what they've done is they've taken all the AQA papers from the old syllabus and they've put it on our website. I don't know what the copyright thing is about it, but seeing as AQA took it off their website, then it's a very valuable thing to have.
yeah.
We've got loads of past papers to do on rates. So the first thing is just some definitions, and then we can do the exam paper. Well, not all of it, just the rates bit.
Yeah.
So what is initial rate for a start, and what are the units of it?
Initial rate, is it the well, it's the starting of the rate, and is it generally the faster part? And
It's the fastest part, and when does that happen? At the beginning or at the end?
At the beginning.
That's it. So I don't know whether you remember my graphs from last week, but they're not very good. But what we'll do is, what would we plot against what?
So is it
Sorry.
Concentration against time?
Yeah, and you could do products or reactants. You could do the appearance of products.
Yeah.
Or the disappearance of reactants. So if it was the appearance of products that we're going to do,
yeah,
what shape would the graph be? But let's label the axes first, because that's important. So do you want to do products or reactants?
Products would probably be easier, actually.
Right, so what I'll do is I'll just put square brackets, which means concentration, and P.
Right.
Could be anything. So how could we, can you give an example of how we could find out what the concentration of a product is?
I should know this, but I don't.
There's all sorts of things, as long as you can see it, like the disappearance of reactants or the appearance of products. So it could be pH.
Yeah.
It could be something going cloudy and covering up across or something like that. I'm sure you've done these.
Yeah, we did one today actually on the iodine one.
Yeah, the iodine clock experiment.
Yeah, I think it was. Yeah.
So what are we going to put on the x-axis then?
Time.
Very good. So now we have to predict what shape that graph would be without any being specific. Just what shape it would be. The products, are they going to be high at the beginning or low? Sorry to interrupt.
Right. They'd increase pretty fast. So it'd be a steep curve and then it'd level off.
Yeah, exactly. That's a good way of describing it. And it would look something like that. And it would plateau out. And how would we measure the initial rate?
Gradient.
Yeah, we do the gradient when t equals 0.
Right.
Which is the initial rate. Because that's the fastest bit. And the other important thing is that we know what the concentration of the reactants and products is then.
Yeah.
Because we've just started it. So as time goes on, the products will increase, the reactants will decrease, and you wouldn't know what was going on. So we use the initial rate. I'm not going to try and draw that on the graph, but what would we write as units? Well, we can put the units on the graph, can't we?
Mm-hmm.
So that's the concentration of the product. So what happens? So what's the units of that then?
Is it moles per decimeters cubed?
That's it. As always. And obviously times in seconds.
Yeah.
So what are the units then?
So moles per decimeters cubed, and then S to the -1.
Yeah. What is order of reaction?
Is that when some parts of the reaction react faster than others? So you've got the first order, second order, and zero order.
Okay, yeah. I'm just going to take another little pause if that's okay.
All right. Yeah.
Don't pause the recording. All right, order of reaction. So again, we're going to have to plot graphs for this. So what would we plot? Oh, do you remember last week there was some misunderstanding about this? The teachers maybe gave you the wrong graph. I don't know really. So what would we plot?
So on the y-axis, would you have rate?
Yes.
And then x, the concentration.
Yeah, not the other way around, because the controlled variable is the concentration.
Yeah.
And we'll just call it A for now. Obviously, in the exam questions, you know, you're going to have to be more specific, but for now, that'll do. So let's say it's zero order. So what would the graph look like?
Is that the one with the horizontal line?
Yeah, it'd just be a straight line right across, because the concentration of A has no effect on the rate.
Right.
Which is good news in a way, because it means we don't have to put A in the rate equation, and the less things that are in the rate equation, the better. Right, so that's zero order. So let's do second. And obviously the graph is going to be the same axes. And this time, sorry, we're going over old ground a little bit. Is it okay?
Yeah, it's fine. It sort of needs rehashing.
Just a bit of revision to make sure that's there, and then we can try these exam questions.
Yeah.
The first one I've got is 2016. And in those days, they were a little bit easier.
Right.
You know, they were less devious. But it's okay. It'll be good practice. And apart from that, we haven't got many questions on AQA. So what we're going to change, the concentration of another reagent, which is B. So what would be the shape of that one? I know I've done it in the wrong order. We've got zero order first, and then second. We'll do first in a minute.
All right. So is it like an upwards curve?
It's like a quadratic graph, yeah.
Yeah.
So it's like half a quadratic. So the rate's gonna go up really fast, but it's not gonna go up in a proportional way. It's gonna go up like that, which I think is what you meant.
Yeah.
Yeah?
Yeah.
Right then. So we'll do first as well. I don't know why I did that next, but anyway, it doesn't really matter. You've got to be flexible anyway. Okay, first order then. I won't put the axes on, you know what they are.
Mm-hmm.
What shape will that be?
So is that a line through the axes?
Yeah, through the origin, 45 degrees ish.
Yeah.
It won't be on my graph. Not quite. So that is first order. But we need to use mathematical expressions to use these graphs to some effect. You can imagine how labour intensive this is. Like I said last time, you've got to do a load of experiments measuring the concentration of something with time. Then you've got to plot a tangent, which I presume you would do on Excel or something, you know. And then you've got to plot other graphs. So for lots of concentrations, you've got to do this. So it goes on and on. Anyway, what we know that A is not relevant to this rate equation, which we're going to draw. But obviously B is, and so C. And I suppose I should put this on here because then we'll know what we're talking about. What's on the y-axis again? Obviously rate. Let me just rub out that Arrhenius equation. We'll do that later. Probably not today because the old syllabus didn't even have it on.
Right.
The reason for that, I don't know. And why they put it back, I don't know. But anyway, rate equation for this particular thing. And we'll do some exam questions in a minute because that's all you need to do theory-wise. I'm sorry, you don't spell equation like that, do you? Great, isn't it? Chemistry tutor that can't spell equation. Right then, we can write a rate equation very easily for this reaction, which involves A, B, and C. Doesn't matter what they are just now. So what's the relationship between the rate and C? Concentration.
Right.
This one.
First order.
Yeah.
Right. So is it K and then just C in brackets?
Yeah. I mean, rate is proportional to C. Just so
right.
you can see that from the graph. And there's no other orders to worry about. So that's it. If it isn't a straight line going upwards, then it's either 0 or second. So rate is proportional to C, but we can't calculate anything with that because, well, proportional is okay. If that doubles, that doubles. If that quadruples, that'll quadruple. But we want to be able to actually do calculations, so we'll put a constant in. And now we can just write it like that, which is what you said, isn't it?
Yeah.
But we need to take account of B as well. Normally put them in alphabetical order, but never mind. What should we put to finish it off then? We don't need to put A in it, of course.
And then do you put B in square brackets to
Excellent, yeah. That's it. And you can do that once you know they'll always tell you enough things to be able to do the calculation at the end of the day. All right, so do you think we can do some exam questions then?
Yeah.
Have a go at them, because that's what it's really about, isn't it? So let's get to the exam paper then, which I think is this one. It should be. And let's have a look. So this was 2016 and it's the old syllabus, but to be honest, the questions aren't going to be that much different. Mm-hmm. So this is a bit of a strange one because if you look, normally the table is different. Normally it's the other way around, but it doesn't matter. So we've got 3 experiments.
Yeah.
And this is called the inspection method for determining rates. So what we could do is look at 2 experiments and try and work out what's going on. And we could do with a pair of experiments which doesn't cause problems. Which 2 experiments do you think we'd choose?
1 and 2, because there's a difference.
You could, but the trouble with that is it's a bit awkward. You could do it probably, but going from there to there, that's changed.
Right. Okay.
And so's that.
Mm-hmm.
So that makes it a little bit complicated.
Right.
So what? How about 2 and 3?
Yeah.
Because D doesn't change, so we don't have to worry about it. but E has changed. So
Right.
what we need to do is to know how much it's gone up. So what we do is 1.75 over the other thing. 8.73 times 10 to the minus 1. Maybe you could do that.
Yeah. I got it as 2.00458.
So it's doubled.
Yeah.
Yeah. We'll just say 2, because it's got to be an integer. It's got to be a whole number.
Right.
Now then, what we do is look at what's happened to the rate.
Right.
So the rate is in the third column, and we're looking at experiments 2 and 3. What people do quite often is do an arrow.
Yeah.
Going from experiment 2 to 3. So that's no change, quite obviously. Now, we've already worked that that's times 2. Now, if it was first order with respect to E, then we would know. So let's look at what's happened to the rate when we've increased the concentration of E. But first of all, let's find out where we've done that. So what's happened to the rate is the next thing.
Right. So I've got that as times 4.
Excellent. So going from there to there is times 4. So now we can work out what the initial rate is for D. No, we can't. We can do it for E at the moment. So E has quadrupled.
Right.
No, it's not. It's doubled, hasn't it? E has doubled, but the rate has quadrupled.
Right.
If the rate had doubled, then it'd just be first order, wouldn't it?
Yeah.
But it hasn't doubled. It's quadrupled. So what's the order with respect to E?
So would that be second order?
Excellent. Yes. So that's done. So we'll put that there. Now we need to find out what the order is with respect to the other one, D.
Mm-hmm.
So what about experiments 1 and 2?
Right.
Now, if, say it was 0 order with respect to D.
Yeah.
I'm not saying it is, it might be. But again, we can look at another 2 experiments now. What about experiments 1 and 2?
On D, I've got that as 1.5 times 1.5.
Yeah, so that's times 1.5, which, but let's just do E first. I'll put it on anyway.
Yeah. Sorry.
Going from experiment 1 to experiment 2, that's 1.25. Now, going from 5.81 to 8.73, that looks like double, doesn't it?
Yeah.
So that is that one times 2 as well?
I've got that one as, oh wait, have I put it in wrong? No, I've got that one as times 1.5 again.
That's 1.5. Right.
Yeah, but I might put it in.
That's no problem.
Right.
So if E goes up, sorry, we've already done E, haven't we? Let's do the other one. We know what it is with respect to E. It's 2.
Right.
You're saying let's do experiments 1 and 3 then instead.
Right.
Or something like that.
So
what would happen to this rate here? No, we'll stick with 1 and 2. What happens to the rate here? Is it gone up by 1.5 or not? That's all we need to know.
I'll do it now. It's gone up by 3.
Right, which is double 1.5.
Yeah.
So that tells us we already know that it's for second order with respect to E. So what must be the order with respect to D?
Is it again 2, second order?
It's actually 0 because, well, let me just explain. So that's gone up by 1.5.
Yeah.
Going from experiment 1 to experiment 2.
Yeah.
And this has gone up by 3, which is twice 1.5. And we already know that it's second order with respect to E. But we've also increased the concentration of D. But that's not done anything.
Right, okay.
That's put it up by 3. That hasn't done anything. So it's 0 order.
Right, okay.
Now, there is another thing you can do, which is to work out K first, and then you can do it from there. But really, you need to be able to do it this way as well, because they might insist on this way, or you might get questions where it's impossible to do it any other way.
Right.
So I think that's what the space for working is, in case you want to do it like that. So what's the rate then now? The rate equation. It doesn't ask us for that, but we might as well put it in. We won't put it on the main part. Rate equals obviously a K.
Yeah.
Last rat. I see. Okay. Do we need to put D in the equation?
No.
No, we don't. That was a bit of a rhetorical question, wasn't it? So we don't put naught or anything. That'd be stupid because the rate would be naught. We just ignore it because it's not relevant. And because this hasn't doubled or gone up by 1.5, if it had gone up by 1.5 going from experiment 1 to experiment 2, it would be first order with respect to E.
Right.
So we're nearly there. We need a rate constant, obviously.
Yeah.
They usually ask you to do the rate equation. And what would be the rest of it?
It would be D in square brackets to the power of 2.
E.
E, sorry.
It's E, isn't it? Yeah.
Yeah.
Right. As I say, the way this one's written out or printed out, squared, yeah?
Yeah.
It's confusing. I mean, it's a shame we started with that one because that's the most confusing question I think I've ever seen because of the way the table's set out.
Yeah.
So what we'll do now is we'll look at another paper.
Mm-hmm.
And they're all very similar. Once you've done one, you'll find that they become easier. That's like anything else, really. Right, let's have a look at the list of things that we've got. It'll be a bit slow because we're online as well. So shall we try? This is the Physics and Maths Tutors website, which is all very good. All right then, so we just go and make a cup of tea while we wait for this. That's the only problem with being online as well as trying to download things, but it will appear.
Yeah.
In the old syllabus, they tended to put the rate equations in the same place every year, which was usually the first question. Maybe it'll be the first question, I don't know. Yes, it is again. Okay, so this one, hopefully it'll be straightforward. See what I mean about the graphs? They're the other way around now.
Yeah.
Not the graphs, the table.
Yeah.
So what it's asking us to do this time is probably going to be a different method. This time we've given the rate equation. So there's no point in messing about trying to find it, the order of anything, because they've already told us. Deduce the units of K. We'll do that at the end, but we need to do the calculation first, which is to find out what K is. We got the rate equation. It's just a bit of a rearrangement. So what will we do? Rearrange it. So what we want to do is make K the subject of the formula. We take that and rearrange it.
Right.
So K equals
yeah, so would it be K equals rate over A squared?
Exactly that.
Yeah.
So you're no problem rearranging things. Okay, some people do. They've done GCSE maths and they just forget it all immediately that they finish for the summer, which isn't very good if they're going to do A-level chemistry. There isn't much maths in it, and we will do, apart from the Arrhenius equation, that's a bit tricky. So can you just work out what that is, and we'll just fill it in, assuming it's correct. So we're going to put the numbers in.
Right, so you can use, well, you'd have to use the top experiment one, wouldn't you?
Yeah, that's right, because that's the only one we know.
Yeah.
The data. They actually told us anyway. In the new syllabus, they probably wouldn't.
All right. So would it be 3.3 times 10 to the minus 5?
On the top there, yeah.
Yeah.
And on the bottom, obviously, we've got
4.2 times 10 to minus 3 in square brackets, the power of 2.
Yeah, well, you don't need square brackets because you know it's a concentration anyway.
Yeah.
You can put it in normal brackets, so if you want. So yeah, 4.2 times 10 to the minus 3. And if you could work that out, we've got K.
Right. I've got it as 1.98.
1.98, okay. And the other thing we need to do is find the units, which shouldn't be too bad. So, oh dear, unstable internet connection. They've threatened us with that before though, haven't they? And nothing happened. Okay, so shall we do the units for this? So rate constants, we've already rearranged that, or you have, equals the rate on the top and the concentration of A squared on the bottom. So you can work out what the units are.
Sorry, the sound stopped working for a sec.
Did it?
It's not working.
Oh dear. This is the sort of thing that happens. Right, I can try a couple of things. I can try muting it. Is that any good? Hello? I can't see anything at this end that's causing this. I'll just pause that. Okay, sorry about that. The sound went for a minute. We've got it back. Have we got it back?
Yeah, it's much better.
Right, that's a relief. It just happens sometimes.
Yeah.
All right then, so we can do the units at last. So what's the units of rate? You've already told me that at some point.
Yeah.
We're over here. This is the rate. What's the units?
Moles to decimeters cubed to the -3, then S minus 1.
S to the -1.
Yeah.
You know when you do equilibrium constants?
Yeah.
Which is nothing to do with this whatsoever. That's about how far reactions go. This is about how fast. You also have a constant, but it's completely different from this and nothing whatsoever to do with it. So on the bottom, what have we got then?
So because it's squared, is it moles squared decimeters cubed to the -6?
Yeah. And we can do a bit of counselling. We can do a bit of cancelling.
Right.
And then we'll have the units then eventually when we take it up to the top. So we can cancel this out because we've got two concentrations down here. So moles cancel out with moles squared just to give moles, don't they?
Yeah.
And on the top, we've just got 1. So that becomes moles squared. No, it doesn't. It just becomes moles, doesn't it? What happens to the dm -6?
It just becomes dm -3.
Excellent, yeah. Now, we don't want to know what 1 over the units is. We actually want to know what the units is.
So to get that, do you reverse the signs?
Yes.
Yeah.
And we've still got seconds to the -1 on the top, haven't we? So I shouldn't have done that. Seconds to the -1. You always have seconds in it. Whereas with K, the equilibrium constant, sometimes you don't have any units.
Right.
You will always have at least seconds to the -1. So if all your units cancel out, then you've probably forgotten to put the seconds in. That's all. So let's write the final units then.
So is it moles to the -1?
Excellent, yeah.
Decimeters cubed.
Yeah.
And then just S to the -1.
That's it. So you can do that very well. How come you had trouble? Which did you have trouble with in class then? Or was it just doing examples in class?
It's the bit at the start with the table when I'm initially working out whether it's first or second or zero order. That bit confuses.
That's the hardest bit, yeah. It's a bit baffling sometimes.
Yeah.
Especially when they put the rates, sorry, these down here and the numbers at the top, like they did in the other question. But I think, to be fair, you've got to be ready for both. You know,
Yeah.
might just do it. So let's clear all this up and see if there's anything else to this one. And if there isn't, then we'll move on to the next one, which will be 2005. And then we could use it to complete the reaction. To complete the table, but that would take quite a long time, wouldn't it? Mm-hmm. All we do is substitute numbers in. I mean, you can do some of them without even, you could use the old method, the one we just done in the other question. But what would you do with that then? Just substitute them in to the rate equation. That's it, and fill in the gaps. Right. So when you want to do this one, you've got this and this, you've got rate, you just put them in. I don't think we need to do that now, do we? Because it's very time consuming.
Yeah, right.
But we might as well address that random question. The reaction is zero order with respect to V. Well, we know that because it's not in the rate equation. Mm-hmm. State the significance of this zero order for the mechanism of the reaction. Now, have you talked about something called the rate determining step?
Yes, vaguely, yeah.
It's the slowest step. It's the slow step in the reaction.
Yeah.
And if B is not in the slowest step, then it doesn't affect the rate because that'll happen quickly.
Right.
And then it's only A that affects the rate. Because once B's done its bit very quickly, then A's got to do its bit. That's not very scientific, but how would we put that into sensible scientific words?
So would you just put that it's one step? Wait. Yeah, I mean,
you could just say it's not involved in the rate determining step.
Yeah.
Because everything in the rate equation has to be in the rate determining step, otherwise it wouldn't affect the rate. So that's that. So should we try 2015?
Yeah.
Back to the menu, which, it takes a minute or two, but there's nothing I can do really about that. Okay then. Was that 2015 or 2016? Do you remember?
2015, I think. I think we're looking back.
Yeah. Okay, this one then. Whenever it's ready. That's nothing. I've got a computer behind this one that is so slow at the moment I can't even use it for this. It's just not capable of it, Not up to it. So you can see this is the old syllabus. Now, if you're looking for a rate equation to practice, you know straight away that isn't one.
Yeah.
Because it's an equilibrium for a start, and it's got thermodynamics in it, so it's not one. It's not that one. There'll always be rate questions. You won't be lucky enough to get an exam without it. This is nothing to do with rates. This is the equilibrium constant, which people tend to mix up with the rate constant. We will get there. So when I said they usually put it at the start, I meant sometimes they do. Have we done that yet? Acid dissociation constants.
No, I don't think we have.
No, so there's quite a bit to come yet. But don't worry, it'll be you can do all this. This is one of the hardest topics actually. Okay, especially the Arrhenius equation. It doesn't need to be. Right, there we go. Let's have a go at this one. They're not very generous with the marks, are they? And notice that there's only one mark for finding the order. So what we don't want to do really, well, we can't write a rate equation anyway because we don't know what the orders are. So what would we do there? Either just take, again, they put the things the other way around now, haven't they? So have any of them stayed the same? Are there any? Yes.
There is on experiment 2 to 3 on the middle bar, isn't there?
Yeah.
Yeah.
So that's not done anything. So it's best to do experiments 2 to 3, isn't it? I think. Compare 2 and 3.
Yeah.
And then we can see what's happened to the concentration of A, and then we can find out what's happened to the rate. So just the same as before. Hang on, I've got to put my pen on. Right. And so going from there to there, can you work out what's happened?
Is this from experiment 2 to 3? Yeah.
Yeah, so it's 3.6 over 2.4.
Yeah. So I've got that as 1.5.
That makes sense because it's obviously not double.
Yeah.
You can see that because that'd be 4.8, wouldn't it? So it's 1.5. It's usually best to check it on the calculator.
Yeah.
Then we can look at what's happened between experiments 2 and 3.
Right.
With the rate. What's happened to the rate?
Right, so that's, oh, thanks. I've got that as 2.25.
2.25.
Yeah.
Well, is it first order or second order?
Second order?
Yeah. I don't know why it's 2.25.
I might have put it in wrong. I'll
I
try
doubt
again.
it though, because that would be 3.6 if it was double, wouldn't it? Well, anyway, the nearest integer. It's 2.25, you reckon?
Yeah, I think so. I'll type it in again, but yeah, still got it as 2.25.
So what's 1.5 squared then? Because
2.25.
exactly. So it's not, what is it then?
So second order.
Second order, and then we look at what it is that we're changing. We're changing A, aren't we?
Yeah.
So all we have to do after all that is to put a tick in the box, and they'll generously give us 1 mark. So don't worry about 2.25 isn't close enough to an integer to just say that'll do. But it wouldn't work anyway, would it? Just to explain that a little further. If it's second order with respect to A, rate is proportional to A squared, isn't it?
Yeah.
And we've just shown that because the concentration has gone up by 1.5, but we need to square it. And when you squared 1.5, you got 2.25. Yeah?
Right. Yeah.
Great. Now we've got to do the other one. You don't need the table. I'm not going to scroll down because I don't have to rub everything out. So what do you think the order of reaction is with respect to B? So we need one where we're going to change B. You could do 1 and 2.
Yeah.
You could. That's probably best, isn't it?
Yeah.
So let's look what's happened to the concentration of A first. Is that 1.5 as well?
Yeah, 1.5.
What's happened? Has it had any effect? Yes.
Yeah.
And it's the same effect as before.
Yeah.
A has gone up by 1.5. So the rate will go up by 1.5 squared, which is 2.25, which is the same as the other one.
Yeah.
But B's changed as well. So it should be more than that. But it's not. B's gone up by something, I don't know what. That's about 1.5 as well, is it?
Yeah, it is.
Yeah. Well, that's gone up by 1.5, but it hasn't had any effect.
Right.
Because that's gone up by, when you go from 1 to 2, or it's still gone up by 2.25.
Yeah.
So what's the order with respect to B? We can just write it in, we don't need
to. Zero order, right?
Yeah.
Because it's happening.
And the rate equation would obviously be, obviously we need a K.
Yeah.
Not supposed to say rate, but because of this dodgy internet connection. A bad workman always blames the tools, apparently. Rate equals K.
Yeah.
And what's the rest of it?
A in square brackets squared.
Yeah, so it's a nice simple one.
Yeah.
Nice simple rate equation. And if they asked us to do, which they might do in a minute, we could put some numbers into that and work out what's going on. Find some answers. All right, let's see what they want us to do next. Oh. Well, we've done that one. Now this is a different one. The reaction between two different compounds C and D is studied at a given temperature. So this time, they've given us the rate equation. It's nothing to do with the previous bit. And we need to do a calculation. And I think you can do that without any help, really. We want the rate constant, so we're going to have to do the usual thing, which is to rearrange it a bit.
Yeah. Yeah.
So that's what's going to be the subject. Then you're going to put the numbers in.
Right. So is it?
I could check.
Rate? So it's rate over C and D squared. So would it be 6.64 times 10 to the minus 5?
Say again, please.
6.64 times 10 to the minus 5 at the top.
Okay. How do you know? Have you written down the numbers?
No, it says it at the top.
Oh, sorry.
On the question.
I'm a bit thick, aren't I? All right, that's the rate. Initial rate, remember, and you know how we get those. We started off with that.
Yeah.
And on the bottom, we just put in the concentrations. It's not too bad, is it? So what do we put?
So 4.55 times 10 to the minus 2.
Yeah.
And then 1.7.
Yeah, that's the one, isn't it? That's D. And it's second order with respect to D. 1.70 times 10 to the minus 2.
And then squared, though.
Yes.
Right.
So this is just practice, really. And then you just put all the numbers into your calculator and hopefully get something. You don't know what it's going to be, so it could be anything. So we'll just have to believe whatever the calculator tells us on this one.
I've got it as 5.049. So, yeah.
You might, yeah, 3 significant figures. You might want to round it up a bit.
Yeah, so
you know, 5.04, but they're not too bad with that.
Yeah.
As long as you don't put too many decimal places or too few. Unless they actually say, give your answer to so many decimal places or so many significant figures. So I presume they want the units as well, a bit predictable. So what we could do is we could put the units into the equation. Maybe you don't need to do that, but we could.
Yeah.
So on the top, we've got moles to the minus 1.
Yeah.
Per decimeter cubed. It's not minus 1, is it? Dm minus 3.
Oh, so it's nothing on the top, is it, for the moles?
There's nothing, no. Because moles to the 1 is just the same as moles. And on the bottom, it's easy, isn't it, really? What should we put down there?
Oh, the volume's gone off again.
So what we're going to stick on the bottom line? What, you've lost the sound again? Has the sound gone again?
It was a bit weird.
It was a bit weird, but then again, we've got 2 internet connections that we're relying on.
Yeah.
It's quite heavy usage because, you know, we've got things on the screen being drawn. We've got streaming sound and video.
Yeah.
I presume you can see my video.
Yeah, I can. Yeah.
I mean, it's not really serving any purpose because on my screen, which is the thing that's being recorded, it's just got a square with Soneva on it.
Yeah.
So that's not going to be much use. So I'm really wasting bandwidth, aren't I? So what I'll do is I'll stop the video, to be honest. It doesn't add anything, does it? It probably takes away. Okay, so I'll stop it. Is it gone?
Yeah.
All right then. And on the bottom, we can just finish it up now.
Yeah. So
We put in C.
yeah. So that's moles deciliters cubed to the -3.
That's for C, yeah. And then we need to square this one.
Yeah. So is it moles squared to the deciliters -6?
Excellent. Now we can do a bit of cancelling.
Yeah.
Obviously, that and that go away. And we want to get these 2 up to the top, don't we? So we've got the units now.
Yeah. So just do you reverse the units so they go?
You reverse that and you reverse that. So it's moles to the -2.
Yeah.
DM6.
Yeah.
Don't forget the seconds to the -1.
Right.
It's a classic mistake, that, forgetting the seconds.
Yeah.
And I do it as well, so it's just one of those things.
Yeah.
Especially if you've just done a question on equilibrium, you might still be thinking about equilibrium. And then you might forget to put the seconds in, because obviously there aren't any seconds in equilibrium. Because it doesn't matter how long it takes, it's just how much you get of the product.
Yeah. Right.
I've done the usual mistake. Right, this is great. We'll try again. When that's finished scrolling, we can get back to the question. So this is what happens when you try and do things. I managed to do the whole lesson without actually doing that for once. I don't know how to stop this. Right. It's very slow and I want it to stop. Right. Has it stopped? Yes. No. Okay, now we can go back. Right. So this is the last bit of the question. We've done the 3B1. Now we need to do 3B2. It's not going to be difficult.
Right.
So what do you do? It's repeated at the same temperature because temperature obviously affects the rate. So you have to keep the temperature the same.
Right.
And all the concentrations go to half.
Right.
Same temperature, new initial rate.
Because the volume.
Sorry, go on.
Sorry. Because the volume is doubled, does that mean the initial rate doubles?
Well, we can look at C and D. What's going to happen to the concentrations?
Oh, they're gonna halve.
Everything's going to halve, yeah. So what's going to happen to the rate when we halve C?
Right. It's going to half. Right? Is it going to half?
We're going to halve C and we're going to halve D as well.
Right. So, yeah, because they halve, does that mean the rate's going to halve as well?
Well, it's going to do more than that.
Oh, right.
Because if C goes down by a half, it's going to affect the rate, isn't it? The rate's going to go down by half.
Yeah.
So I don't think what would you think would happen? Obviously, it's going to affect the rate. I don't think the equation's going to change just because you change the concentrations. But they must want, something for a mark. Am I missing something here?
It just says that the volume's doubled. It doesn't say that anything else changes. So,
obviously the rate would go down, wouldn't it, if we halve the concentrations?
Yeah.
But they're asking for the new initial rate. I thought they meant the rate equation. Okay, no problem.
Right.
We're going to halve C, so we need to times the rate by 0.5, yeah?
Right.
So the concentration of C is times 0.5, isn't it? Because we've added all that solvent.
Yeah.
So that means that goes down. So the rate's going to go down by a factor of 0.5. It's going to halve. Now, D is also multiplied by 0.5 because that's halved as well. But it's second order with respect to D. So what we need to do is, what do you think we need to do to sort that one out? That's gone up by 0.5. That's gone up by 0.5. So the rate needs to be multiplied by 0.5.
Right.
And what else does it need to be multiplied by?
0.5 again?
Yeah, but this time we're going to have to square it.
All right, okay.
Because of this. So we're going to multiply it by a half because of C, and we're going to multiply it by 2. Can you just square? Mine's gone. What's 0.5 squared? 0.25.
2.25, yeah.
2.25. So it's going to increase by that.
Yeah.
But it isn't going to increase, is it? We're halving it. 0.5 squared. I don't think it's 2.25, is it? 1.5.
Oh, sorry, yeah, 1.5, isn't it?
1.5. So all we need to do, see, the rate must go down in both cases. So it's going to go down by 0.5 because of C.
Yeah.
It's going to go down by 0.5 because of D, but we have to square 0.5, which you've just done. So all we need to do is multiply that by 0.5 and then by 1.5. That will be your new rate. I mean, obviously, if you change the concentrations, it's going to change the rate. So all you do is put the numbers in. It doesn't really matter what the answer is.
Right, so I've got that as, 4.98 times 10 to the minus 5.
4.98
yeah.
times 10 to the minus 5.
Yeah.
That's okay. Is that okay with you?
Yeah. Yeah.
It makes sense.
Yeah, it makes sense now, yeah.
That's quite difficult, especially if, you've only just started doing rates. But that's a useful one to be able to do.
Yeah.
You see, the questions are similar, but they can always put a twist on it. So you can't revise for one particular type of question because they like to fiddle around with them, especially now with the new syllabus. Anyway, we'll finish in a minute, but let's just see if there's any more of this. Turn that off. Don't touch the thing. Let me just. So we've done that. I think that's probably it. Yeah, turn over to the next question. And then it goes on to organic chemistry.
Right.
So we've had a bit of everything today. We've had me coughing. We've had the sound going. One of those things. This is what happens.
Yeah.
All right, then. Should we leave it there for today?
Yeah.
Are you okay for next week?
Yeah, I think so. I can't think of any reason why not.
And you usually let me know topics, don't you, beforehand? So.
Yeah.
So it was an interesting lesson. I hope it was useful.
Yeah, it was. Thank you.
Because we've been kind of exploring the questions together, as you can probably tell. I hadn't looked at that one. I've probably seen it before years ago, but we're going back 5 years now to these. Anyway, so we'll leave it there and hope to see you next week, and we'll do some more of something. Okay.
Yeah. Thank you.
Thanks. Bye.